Hi guys, so this is lesson 3 of National 5 Pythagoras, and we're now going to deal with the converse of Pythagoras' theorem, which is essentially just proving whether or not a triangle is right angled. So this involves essentially just using Pythagoras' theorem in a slightly different way, and writing, always really important. We must write a statement at the end of each question, basically saying, is it right angled, yes or no? And there's very, very specific things that need to be written in this statement, and that's given to you in this sort of box in your notes. We'll come back to that, these 3 bullet points, when we get onto our statement at the end of the question. We'll come back to that in a second. So if we just look at this example, they'll usually will always be in a sort of real life context. In this case, we've got Humza is building a raised deck in his back garden. He cements 3 posts into the ground, which will have decking boards nailed to them. Now, to meet building regulations, the boards must form a 90-degree angle at post A. So the 90-degree angle must be at point A. We don't know if it is or not. That's the whole point of this question. So we can't put a right angle in there. It looks like a right angle, but we don't know for certain until we actually calculate it. So it says post B and post C are 10 metres and 10.5 metres from post A. So that's represented by A to B being 10 metres, A to C being 10.5 metres. And post B is 14.5 metres from post C. So the difference between these types of questions is we already have the 3 sides. So we're not trying to find the missing side. What we're trying to do is work out, does these 3 sides satisfy Pythagoras' theorem, and therefore does it mean the triangle is right angled or not? So here's what you're going to do. We can't put a right angle into our diagram because we don't know if it is a right angle, but we know the right angle should be at A, which means that the hypotenuse longest side should be this 14.5. So that is the side we're going to call C. A and B doesn't matter. Call them whatever you want. I'm going to call 10A. I'm going to call 10.5B, and then we are going to not. So here's fundamental. We do not know if this is a right angle triangle or not. So if you write this, you get no marks because we can't make that statement yet. We don't know if it is a right angle triangle or not, so we cannot write that. So don't write it. What we're going to do is we're going to set it out like this. We're going to draw a line down the middle. We're going to put C squared on this side. We're going to put A squared plus B squared on this side. So we're going to work them out separately. If the 2 numbers at the bottom are the same, it means that C squared does equals A squared plus B squared, and it is a right angle triangle. If the numbers at the bottom aren't the same, it just means it isn't a right angle triangle. So C squared is going to be 14.5 squared, which we're just literally going to type that in and work it out. So I'm getting 210.25. And then A squared plus B squared is 10 squared plus 10.5 squared. And we're just going to work that out. Okay, and I'm getting 210.25. So the numbers are equal to each other. Therefore, C squared does equal A squared plus B squared. Therefore, it is a right angle triangle. So we need to now summarize this in a statement. So if I can quickly kind of scroll up to the 3 things that we need in our statement. They're in this box at the top of your notes. So it says you need a numerical comparison. Okay, so you need to say, for example, 74 squared does not equal 48 squared plus 55 squared. If you say just the letters, you will not get the mark. You need to state whether this means the triangle is right angled or is not right angled. You need to say the word right angled or is not right angled. And then you need to answer the specific question depending on the context. So therefore it does meet building regulations, or therefore it doesn't meet building regulations. So we have all this now to put in a statement. So we'll do this at the side here. So first bullet point is the numerical comparison. Now, the numbers do equal each other. So we say since 14.5 squared equals 10 squared plus 10.5 squared. That's bullet point 1. We've done the numerical comparison. The triangle is right angled. Is, and you can underline is, right angled at A, at post A, if you want to say that, at post A. Going to try and relate it to the context of the question. At post A, then again, answer the specific question. Doesn't mean it doesn't meet the building regulations. It says the boards do have to have a 90-degree angle, so therefore yes, it meets the building regulations. So yes, it meets buildings regulations. Meets the building regulations. So the statement is kind of half the battle here. The process, you have to split up. You cannot, remember, say they equal to each other. You cannot start with the formula because we don't know if it works or not. We just split it up with a line down the middle, work out c squared, work out a plus b squared. If they match, we just write what we've done over the right hand side there. If the numbers didn't match, all we do is just say, since that 14.5 squared doesn't equal, and you can see an example of doesn't, it's up in this top line bullet point here, it's just the equal sign with a line through it. You would just say doesn't equal, you would then say the triangle is not right angled, so then it does not mean building regulations. So you just say the exact opposite basically. So you need the working and then you need a clear statement covering those 3 bullet points.